Let's talk about free fall. Free fall is a special case of kinematics. It's not very different from any of the other problems in graphs and things we've been doing. The difference is that it's a very particular subset of an accelerating object. So here's what you have to know. Acceleration for an object in free fall is always negative 9.8 meters per second squared. There is never an exception. That's what it always is. It always points down. Gravity's always attracting things. So it can slow something down that's moving up, or it can increase something's speed that's moving down. You may not include air resistance. They're not going to tell you if you're moving in free fall and they let you know it's a freely falling object, then you must ignore air resistance. And you could be moving up or down when you're in free fall. I know that's misleading. The name is silly, but when you're in free fall, you might throw a ball up. It's in free fall even while it's moving up, and then it's in free fall while it's moving down. And it only includes vertical axis motion. We're going to talk about two-dimensional motion when we do projectiles. So acceleration due to gravity is a constant. We use the symbol little g for that. It's just acceleration. You might see it as acceleration with a sub g, but mostly we write it as g. It's on your equation sheet. You don't have to memorize it, although you know it, right? It'll be on there. But acceleration is due to gravity. And this acceleration is negative 9.8. It's always constant on Earth. We're never going to worry about it changing. There's only two possible motion diagrams because either you're decreasing on the way up or you're increasing on the way down. That's it. Those are your two choices. So a couple of details that make the word problems easier to understand and interpret. When they use the word drop, you're assuming you're holding something up and you're releasing it. So initial velocity is 0. When you're throwing something, that's an assumption that the initial velocity is greater than 0. Okay? When any object is at maximum height, the definition of a maximum height is you're no longer moving up higher, but you haven't yet started to move down. So at that position, that velocity is 0 at maximum height. The trajectory is symmetrical. As you throw something upwards, right, and it rises to this highest point, and then it falls back down, right, at similar positions, like here, on the way up and on the way down, it took the same amount of time, and it's the same speed, but in opposite directions, right? So it's the same value of speed, but one's going upwards, the other's going down. So there's this symmetry about that trajectory. Trajectory is just a fancy name for a path, right? When they say that an object hits the ground, it's no longer in free fall. So you cannot worry about when it hits the ground until we learn how to do problems when things hit the ground. But we haven't done that yet. So when you are hitting the ground, when you've gotten back to ground level, that's when you're at maximum speed. You're not at rest until you come to a stop. So that's a misconception. The other thing to know is that it's totally independent of mass because we don't worry about air resistance. So it doesn't matter what size object, we're always going to be moving at the same acceleration regardless of the mass. These are some dot diagrams of freely falling objects. Are these all right? Which one is the correct one? This one shows constant speed. Is that possible? No, right? Can't. You have all things in free fall have the same acceleration. This one is showing increasing speed down, right? So that's possible. So this looks good. This one shows increasing and then it looks like it's constant. That's not possible. And this is constant but with bigger gaps. So the only one that's possible is this one. No, this is very blurry, sorry. So the graphs of position versus time and velocity versus time, because freely falling objects are pretty much the same, right? They all obey the same set of rules, then the graphs are very similar. So you've got decreasing speed in the positive direction till you get to max height, where velocity is momentarily 0. Then you're going to increase back down to the ground. And since your velocity is negative, you have this negative slope. right, for position versus time. Where this here is your maximum height, here's your origin, you're going up, you're rising, and then you're falling. So this is going to be your y position on, and this is going to be the elapsed time. Your velocity time graph, you're starting with a big velocity because you're throwing the ball or whatever it is upwards. So it starts with a big velocity and then it slows down until you get to this maximum height where velocity is 0, right? So velocity is 0 at max height. And then you're going to turn around and come back in the negative direction, back down to the ground. Now, why is the slope constant? This is a straight line, which means that it's a constant slope. Well, the slope of a velocity time graph is acceleration. And acceleration of a freely falling object is always negative 9.8. So you have this negative slope equal to 9.8. So of course, you know, if you're only rising or you're only falling, you'll just have a section of that graph. To solve this problem, we're going to start by making a drawing of this ball that's thrown up into the air with an initial speed of 12 meters per second. And we're trying to find how high it goes. So if we're throwing it upwards, we start down here, here's the ball, and we're going to end up here. And so the initial velocity is given. So I'm going to label that, right, initial speed of 12. And then we need to label the other thing. So the way that I like to do this is I'll label initial velocity, final velocity, initial position, final position. Acceleration is between the two, and so is time elapsed. Although sometimes people like to do time initial as 0 and then time final would be that time elapsed. So this is delta t. So it's up to you. Some people also like to do your change in distance, which is going to be your final position minus your initial position, and this is your final time minus your initial time. So, but there's a couple different right ways to do it. So what are you being asked for? How high does it go? So that is maximum height. And the reason why it's maximum height is because you're looking for what's the maximum height that it goes. It's implied in the statement. It doesn't say how high is it after 3 seconds. You know, it's not saying anything like that. So the implication is that it's not going to go any higher and it's not going to yet start down. So we're looking for that maximum height. At maximum height, the final velocity is 0. Well, at the maximum height, velocity is 0, period. So you always know these things go together when you want max height. Okay, the initial position I'm going to make 0. So in other words, I'm going to make this y-axis, and I'm going to say that the beginning is 0. I don't know anything about the time, and I'm not asked for the time. So when I summarize this information, I know, right, and we have like a little straight list, and you might wonder why I do this stuff and this stuff, and I'll show you why. So if I do, this is 12 and this is 0, we know acceleration is due to gravity, it's 9.8, and because acceleration is down, it's free fall, it's negative, and my displacement is what we're trying to find, and we don't know time. So this list does something different than this picture. The picture helps me to comprehend and understand what's happening. The list helps me to pick an equation. So I need an equation that has VI, VF, A, and delta D. And so therefore I'm going to use not that equation, I'm going to use this equation because it has all of those variables. So V final is 0, V initial is 12, this is negative 9.8, so I can solve for delta D. So this is, I'm subtracting 144 to the other side. 2 times 9.8 is 19.6. And so when I take out my calculator, negative 144 divided by negative 19.6 gives me positive 7.35. Now, does the positive value make sense? Well, it does, because I've moved from the ground up in the positive direction. Okay. Let's try, oh, that's the same problem. A water balloon is dropped from a 10-meter high window. How fast is it moving when it hits the pavement? So now we're starting here. Here's our water balloon in the beginning. Here's our water balloon at the end. And if I set up the same axis and make the end 0, right, when it hits the pavement, I'm looking for this velocity. My initial velocity, since it's dropped, that's velocity of 0. It's a 10-meter high window, so I know that this position I'm starting at is 10, and my final position is going to be 0. Again, we know the acceleration is due to gravity, is negative 9.8 meters per second squared. I'm moving down, and my acceleration is down. So these should both be negative. So I should end up with a negative velocity. So we'll talk about that. And we don't know anything about our time elapsed. So once again, if you make this little quick list of our information, we end up with a different unknown, but the same equation. So my displacement, remember, is going to be the change in y, right? I mean, it's going to be v final minus v initial, which is 0 minus 10. So I get negative 10 meters. So I'm going to use this equation. So it's going to be v final squared is what I'm solving for. This is 0, 2, negative 9.8, and negative 10. So I'm going to do the square root of 196. So the square root of 196 is going to be 14 meters per second. Now, if you remember, we said, oh, my velocity's got to be negative. How can this be negative? And my calculator ends up positive. That's because when you take the square root, that means the answer can be positive or negative, right? Because negative 14 times negative 14 is 196, and positive 14 times